Hello friends, today's topic of discussion is HDL metabolism. HDL means high density lipoproteins. There are 5 important lipoproteins that are chylomicrons, VLDL, IDL, LDL and HDL. All of you know that lipids cannot be transported alone in the plasma. So it has to be conjugated with something which is soluble in water. So it is complexed with the protein, and these compounds, they are known as lipoproteins. So HDL is a major lipoprotein. Okay, and it is responsible for reverse transport of cholesterol. What do you mean by reverse transport of cholesterol? It is a transport of cholesterol from peripheral tissues to the liver and responsible for metabolism or elimination of cholesterol from the body. That's why it is very important. So it is a very important LAQ as well as SAQ, and it is an important question in the Viva, practical Viva. What is reverse transport of cholesterol? What is LCAT? What is the role of polyunsaturated fatty acid in esterification, and so on. So there are 4 basic steps in the HDL metabolism, that is synthesis, maturation, formation of HDL2 and uptake by the liver. These are the 4 important steps in the HDL metabolism. Where it is synthesized? It is synthesized in the liver and intestine. What do you mean by nascent HDL? So we will see that. So synthesis of HDL particle occurs in the liver and intestine. Liver and intestine. So it is synthesized as discoidal particle. Okay, so it is synthesized as discoidal particle. So it is a disc, and this one is, it is made up of phospholipid bilayer. This is phospholipid bilayer. So it is phospholipid bilayer. It contains free cholesterol, and major lipoprotein in the HDL is ApoA1. So this is known as discoidal HDL. Okay, it is newly synthesized, that's why it is nascent discoidal HDL synthesized by the intestine and the liver. While liver HDL, it has also ApoC2 and ApoE. Okay, the intestinal HDL acquires this ApoC2 and ApoE from the liver HDL. So it is synthesized from the liver and intestine as a discoidal, means nascent disc shape, means discoidal HDL. Now this nascent discoidal HDL, it is secreted in the plasma. It is secreted in the plasma, where the enzyme lecithin cholesterol acyl transferase, LCAT, get attached with this nascent discoidal HDL. Okay, with the help of A1, this LCAT attaches to the discoidal HDL. Now from the peripheral tissues, there is transfer of cholesterol via the ATP binding cassette transporter proteins. So ABC proteins, with the help of ABCA1, ABCG1 and SRB1 receptors. Okay, with the help of these ABC transport proteins, means ATP binding cassette transporters, cholesterol from the tissues and various lipoproteins. Cholesterol from the tissues, here is the cholesterol. From the tissues, it is taken up by this HDL. It is taken up by the HDL. Now what is the role of LCAT? LCAT causes the esterification of this cholesterol. This cholesterol attaches this disc. Okay, once it attaches to the HDL disc, there is esterification of cholesterol occurs. The phospholipid lecithin the fatty acid from lecithin, that is C2 position of lecithin, transport to this cholesterol with the help of this lecithin cholesterol acyl transferase, and results in formation of cholesterol ester. With cholesterol, it forms cholesterol ester. It forms cholesterol ester and lysolecithin. Okay. Now this cholesterol ester being hydrophobic. Okay. This cholesterol ester being hydrophobic moves to the interior core of the HDL. So now this cholesterol ester moves to the interior of the HDL particle. That's why it becomes spherical. So this is the HDL particle with cholesterol esters. It contains major apoprotein, that is A1, ApoA1, then C2, ApoE. These are the major apolipoproteins of HDL. Okay, so by taking this cholesterol from the peripheral tissues with the help of ABC transporter proteins, this transporter proteins helps in the transport of cholesterol from tissues to the HDL particle. This cholesterol attaches to the disc of this HDL. Now this enzyme, that is lecithin cholesterol acyl transferase, LCAT, causes esterification of cholesterol with the help of fatty acid from the lecithin. This fatty acid, which is on the second carbon of lecithin, it is removed by the LCAT and attached to the cholesterol at the third position, third carbon. So it becomes cholesterol ester. Now being hydrophobic, this cholesterol ester moves to the interior of the HDL particle. Now HDL particle becomes spherical. HDL particle becomes spherical, and this particle, it is known as HDL3. This is known as HDL3, which contain lot of cholesterol esters with the help of this LCAT and A1, ApoA1. Got it? This esterified cholesterol from HDL3 moves to the other lipoproteins, that is VLDL, LDL. It is to the VLDL and LDL with the help of CETP, that is cholesterol ester transfer protein. With the help of this protein, there is transport of cholesterol ester from this HDL to other lipoproteins in exchange of TG, in exchange of triacylglycerol, and it results in the formation of the particle that is known as, with more amount of TG as compared to HDL3, it is known as HDL2. It is known as HDL2. And this cycle, that is conversion of HDL3 to HDL2, it is known as HDL cycle. Now in next step, it is taken up by the liver with the help of HDL receptors. HDL receptor, which is scavenger receptor B1 family. So B family 1. Scavenger receptor B1, this is taken up by the liver. And only cholesterol ester part is taken up by this receptor, while A1 remains as it is. So cholesterol ester enters the liver, where it is excreted in the bile. Where it is, this cholesterol, it is excreted in the bile, or it can be converted into bile acids. This cholesterol esters, it is and free cholesterol, it is converted into bile. It is excreted into the bile as a cholesterol, or it can be converted into bile acids and metabolized. So this is this transport of cholesterol from peripheral tissue via HDL to the liver. It is known as reverse transport of cholesterol. Okay. So what is the role of HDL? It is responsible for reverse transport of cholesterol. What is the role of LCAT, that is lecithin cholesterol acyltransferase? It causes the transfer of fatty acid from lecithin, which is attached at the C2, and mainly it is a unsaturated fatty acid. So it transfers the fatty acid from lecithin to cholesterol, third position of cholesterol, and results in formation of cholesterol esters. This is the role of LCAT. What is the role of CETP? CETP helps in the transport of cholesterol esters to the other lipoproteins, while it also helps in transport of TG from other lipoprotein to HDL and helps in the formation of HDL2. What is difference between HDL3 and HDL2? The TG content. HDL2 contain more TG as compared to the HDL3. Got it? So this is a role of cholesterol or HDL in the transport of cholesterol. Now what are the metabolic diseases related with this HDL metabolism? So it is known as familial alpha lipoprotein deficiency. It is known as familial alpha lipoprotein deficiency. It includes mainly the Tanger's disease. Also one is there, that is fish eye disease, and another one is there, that is A1 deficiency, ApoA1 deficiency. So these are the diseases related with the HDL metabolism. Okay. So due to deficiency of these, there is more amount of discoidal HDL in the plasma. So that's why rapid destruction of HDL occurs, and the plasma have lower levels of HDL. And there is increase in the triacylglycerol level, TAG level. There is increase in TAG level. So they are more prone for atherosclerosis. Familial alpha lipoprotein deficiency mainly include Tanger's disease, fish eye disease, and apolipoprotein A1 deficiency. This HDL, it is known as good cholesterol as it is protective in nature. It is responsible for reverse transport of cholesterol, so decreases the cholesterol level in the blood, and it is cardioprotective. So that's why it is known as good cholesterol. So this is all about the HDL metabolism. Keep watching. Thank you.